So good morning, ladies and gentlemen. My name is Jiři Denemark, and I work as a Libvirt maintainer in Red Hat. And today, in this talk, I will be talking about the last year in Libvirt and what happened since last KVM forum. So we had, sorry. It's better now? Okay. So during the last year, we made 11 releases since 1.13 to 1.29, which is roughly the same we made the year before. The number of commits is also comparable. We made more than 3,000 commits during the year, which is a little bit less than the year before, but I think that's mostly because we also focused on creating tests and testing Libvirt, so we had less time to actually develop it. And the good thing is that the number of authors during the year increased in comparison to the previous year. We had 128 developers, and 69 of them, which is 50%, was first-time contributors that never sent any patch to Libvirt before, in the previous years. And the rest of contributors are stable or core contributors. So main contributor was Red Hat, basically. 72% of all commits come from developers from Red Hat, which is less than the year before, when it was 84%, which is good because we are gaining more and more contributions from the community and other companies. The second place in a number of contributions is interesting because it comes from individual contributors, like random people from various companies, or even probably not companies, but the most part of these individual contributors come from Debian and FreeBSD community, mostly from the maintainers of Debian and FreeBSD. And SUSE is on the third place, but they provided roughly the same amount of commits as individual contributors. We also had quite a lot of commits from Fujitsu, Huawei, IBM, and Parallels, who take care of their Parallels driver. So the most active areas during the last year were shared code infrastructure, various utility functions, code that formats and parses XML configuration, storage driver, and security driver. In total, it's 50% of commits changing these shared parts that are used by basically all other drivers in Libvirt. And if you look at what drivers were changed, 50% of the rest of the commits, which means 25% from the total, comes to QEMU Driver. And the other hypervisor drivers have in total about 25% too. And the most active hypervisors except QEMU were LXC, mostly taken care of partially Red Hat, Huawei, and Fujitsu. Also libxl, which SUSE is most interested in as the new driver for Zen. And we got some work in VirtualBox, mostly thanks to Google of Summer of Code project to make it better. And we gained completely new hypervisor thanks to a FreeBSD maintainer, which is called Beehive. So since we are at KVM forum, I will talk a bit more about what features we implemented in QEMU Driver, because it's probably most interesting for you. So in the storage and area, we reworked the storage driver so that other drivers can make use of it. And now most or all, I'm not sure, operations that do something with files like open file, change ownership or something go through the storage driver, so that we gain transparent support for any storage type that we currently support. So from the point of view of QEMU Driver, is the same if we are opening a local file or a file on a cluster or anything else. We just tell it, open this source image, and the storage driver does all that magic behind. We also improved the detection of backing chains, and especially we made it available to the end user and management applications so that they can see what images are actually going to be used and what the backing chain looks like, and if they want to remove some part of the backing chain by committing the changes to the other parts of the chain, they can address individual images or files in that backing chain more easily than it could be done before. And mainly it works with other than local files, because before they had to address the individual parts of the backing chain by path, which obviously doesn't work for network storage or cluster or anything. So now they can just specify that it's the second part of the chain. And we are prepared for trees. We don't support them yet, but we are prepared for them. So that will be usable as well. And we also added support for relative path to backing chains, so that if you, for example, mount or use an image file on a cluster that has some backing chains, they can be specified relatively to the main image. And if you go directly to the server that serves as a cluster, you can look at them and they will work as well, even though you are not accessing them through the cluster APIs. And what Adam is probably going to talk about later today, we also implemented support for block commit to the active layer. So I won't give you more details about that. And Daniel this morning will also be talking about the NEMU Stuff and memory configuration of NEMU. So we made it available, we detect more what parts of memory are assigned to what NEMU nodes, and we provide that in the XML so that applications or management applications can use it for better placing individual domains so that they pin them to the right NEMU nodes, CPUs, memory, everything. And we also added support for huge page base, especially gigabyte huge pages. Another area that could change is migration. We implemented RDMA migration. The work was started by IBM and finished by Red Hat. And what management applications are interested in is to get a statistic of migration that completed. So far, we were able to provide statistic of migration that was ongoing, but once it completed, we couldn't tell anything. And they want to tell to the user how long the migration took, what was the downtime and stuff like that. So we now support it as well. So let me just briefly mention some other areas that got changed as well. We improved support for some non-Intel architectures like ARM64 or Power. The support is probably not finished yet. We are still working on it, but it's getting better and better. We also now support OVMF firmware so that the guests can be booted using UEFI. And what libguestfs is really happy about, we sped up the startup of Libvirt DDMon by caching what individual QEMU binaries can do. Before, we probed every single binary when Libvirt started. And for example, or Fedora, where there is a huge amount of QEMU binaries, it took a long time. So we now cache all that stuff and only probe for that if QEMU binary or Libvirt changes. And since Libvirt is not only about QEMU and KVM, we also made changes in some other areas. We split Libvirt Python bindings into a separate package to make it easier to provide bindings for both Python 2, 6, 2.4 something, and 3, and also to make it more natural for Python users to install it, so they can use PyPy to install Libvirt bindings. And as I mentioned, we have a better FreeBSD support with a completely new Beehive driver. And as part of another Google Summer of Code project, mentored by Michal Privozník, we gained Wireshark dissector, which is quite nice because we can go into the RPC sent between Libvirt client and Libvirt daemon and just see what's happening there. And the Wireshark dissector is auto-generated, so whenever we change the RPC or add something new to the RPC, the dissector automatically is usable for that. Then Berenjay worked on speeding up a network filter driver so that instead of talking to firewall D command, we talk directly to firewall D daemon using dbus, which caused a huge speed up of any operation that involves network filters. And I already mentioned the improved storage driver, and except for that part, we also have a new subdriver for storage, and it's for ZFS. It was contributed by a community. And I mentioned this already at the beginning. We focused on testing our work, so we have more unit tests, and Pavel Hrdina is taking care of some Jenkins servers that run tests regularly. They check if Libvirt builds on various platforms, RHEL, Fedora, Debian, FreeBSD, whatever, so that we don't regress in what we fixed. So thank you for your attention and enjoy the last day at KVM Forum. Thanks.
Cool.